Okay, so this right here is a little different. We're going to set that off to the side. This is one that I already had. I'm not really going to do anything with this here. Yeah, that's the one I stuck on that controller, which is, I mean, it's still good. But anyway, so batteries like this. Okay, so I'm still going to do. I'm going to pull the tape on this battery. These maybe not, and some of these I'm going to tape for what I believe the same reason these are taped is because you'll see the cell is fine. This is not damaged. It is not punctured. It is not, into the cell itself, and it's not swelling or anything. But there is a little scarring on the outside, and so I'm probably going to wrap these with tape just to protect the outer side if they do take some more hits or anything like that from drone crashes or whatever. And I'll probably put a piece of clear tape with the details that are on here to begin with. Now, in the case of this battery, so I've already checked this one, and it is a really good battery, to be honest with you. And it is already, and most of these I've checked so far, I decided, hey, look, let me bring you guys into this, and let's all kind of share. And so I've checked already, and this one is already storage charged. But this little lead right here, which that looks like they did it right, but that just doesn't look professional. So I think this was an add-on. And so my concern is to confirm that everything is good and solid and well protected inside of here. I don't want any potential shorts. And so to check this battery, what I did was first off count the wires. So if you count the wires here, you've got a total of 4, which means this is a 3-cell battery. You count the little holes in the end, 1, 2, 3, 4 leads, 1, 2, 3, 4. There's 4 wires. So with a LiPo battery, disregard 1 wire and count the remaining, and that's how many cells it's got. So you have 1 wire that is a negative, and the remaining wires are a cell. So if you have 5 wires, it's a 4-cell. If you have 6 wires, it's a 5-cell. If you have 8 wires, it's a 7-cell, so on and so forth. So the number of wires to this connector right here is going to be -1. That's how many cells you've got in the battery. This is something extra. And I don't know if this is maybe some kind of factory and they replaced the ends. My suspicion, because this calls itself a uni-plug system version 2.0. It's a Venom battery. And so my assumption is this battery is designed to hook up to something for high amperage draw or to power something potentially through this lead right here. And so that's the only reason why I think that. But I want to confirm it. So I'm going to pull this tape at some point, maybe in this video, and check the connections in here to make sure everything's good. I see this right here where we've got heat shrink on each one of these connections. And so I am kind of wondering if maybe this plug was replaced, in which case it looks like they did that correctly as well, because I believe, from what looks like, the wires were soldered together and heat shrink sealed. So the way I figured the cells out was by counting the wires. And so this right here is a balanced charging plate. And this right here allows to charge for up to 1, 2, 3, 4, 5, 6. So I can charge 6 batteries at once on this multi-plate. I've got another little small one that has, like, I think one of these and then multiples of these, which is really what I should have on here. Let me see for a second. Let me grab that one. Or maybe not. Or maybe so. But to kind of explain this right here, it goes up to a 6 cell as well. So I could plug it in here, and I could plug any, that way my balance lead would always set up and work through this board right here, and I would just plug my balance charger into whichever one matches the number of cells that's in the battery, up to a 6 cell battery. And then all I would have to do is connect on this lead to my main power leads for charging. But this has everything built into it, so that's why I just went ahead and plugged this one onto it. And that's the one that we're going to go ahead and use. So this battery, I'm going to set off to the side for now, and we will get back to it later. So this battery. Now, if we count our leads, so these appear to be a little jumbled, but to be honest with you, it doesn't really matter. The one lead that is a different color is going to be should be the ground. You've got 1, 2, 3, 4. So you've got 4 wires on here. That makes this a 4 cell battery. So I'm going to plug in to the 4 cell port. Plugs right in. And this right here, now if you look on this battery, I really can't get any information on it. Turnigey, which is a known brand battery. I could peel all this back and probably get the information. The only, this is a, let's see, these right here are 4 cells. This is a 4 cell. So this is kind of the same one. But these, so if you look at these batteries, you count the leads, and there's 1, 2, 3, 4, 5 wires. And in here, you have 1, 2, 3, 4, 5 wires. Now here's the side comparison, side by side, the top comparison, side by side, and a bottom comparison. So why is this battery so much bigger and it's the same number of cells? Because it is a higher amp hour battery. This battery right here is marked as a 14.8 volt. I think it's 1,000 amp hours. I got to get my eyeballs here. That looks like 1,000 amp hours. See if one of these other ones is just like it. See, the top is torn a little bit there too. Every one of them right in that same spot has been hit, or it's got some. So that's at least 1,000 amp hours is what I can see on there. So this is what I'm doing. So you can see that this one, being a much smaller battery, it's the same number of cells, but a smaller battery is 1,000 amp hours. This one right here, so you've got the same height, only the cells are thicker. Each individual cell is much thicker. So this one, I would assume, would probably be a 1,300, 1,500, maybe even a 2,000 amp hour, potentially. What I do or I'm doing, and you tell me if I'm wrong, but what I'm doing with these batteries that I can't read any information on, I'm getting in here, and so we're going to plug this in. So we're plugged into the main board here, and so I'm going to go back to the beginning by hitting program stop, and then I'm going to, well, hold on, let's go twice. I had to hit it twice to get back to the main menu. Let's see, I'm going to go backwards till I get to battery resistance. I'm going to hit enter. So it's checking the resistance on the cell. So it found 1, 2, 3, 4. It found 4 cells, just like we thought. And the first cell is a 12 ohm resistance, and the next 2 are 7s. And earlier when I checked this, it was a 7 on that fourth cell, but now it shows as a 6. So we're going to go back out of that, and I'm going to come up to the battery meter and hit enter. 3.81, 3.82, 3.82, 3.81. So this has really already got a storage charge on it. But just for the sake of argument, we'll go back to the main menu and just hit stop back until you get back to your main menu, and you can cycle back through your options, which will be your different charge protocols, as well as this battery meter and the resistance meter. So when you're testing unknown batteries, I definitely recommend that you go into your resistance to check the resistance on the battery pack, because it will check each of your cells. If you go into here, now if you don't plug in this main lead, I found that it won't find the battery. You can still get a individual cell reading, but you can't do the resistance without this plugged into it. And so that's why I'm making sure that this plugged in. You should be safe as long as you don't start charging yet. And I say should, you do this at your own risk. But so the first thing you want to do is hook it up, go in here, check your resistance to make sure you don't have a high resistance on any of these cells. Now, I don't know exactly what the specific numbers are, but I have read somewhere that once you get up into like the 40s and 50 ohms on a cell, it's really getting in bad shape. And that may even be too high. To me, if I seen 20, I would be very leery of a battery. And I already know that I've got one cell in here that's showing a higher resistance than the rest. So let's go ahead and go to our Lipo. Let me find it. Lipo. So we're going to go to Lipo. Now, this is my other precaution, because like I said, you've got these smaller cells, which is 1,000 amp hours, which would be a 1C charge rate of 1 amp. So this battery, and this is guesswork, and that's why I'm checking the temperature to make sure these don't get hot. But if I can't even imagine half an amp being too much for any of these batteries. If you look at this one right here, this one is a 2-cell, a 7.4 volt, and it is a 1,000 milliamp hour, which is, this can be charged at 1 amp. That is 1C is what you would charge this at. And so this one, you would charge at 1 amp. So what I'm doing when I get to the Lipo, then we're set up on here, hit enter, and the first thing it does is amperage starts flashing. Now, hold on, let me back out, because I did do something wrong here. Once you get to your Lipo setting, you want to back up. You never, in my opinion, and what I've read and watched on YouTube, you don't charge. You can set this up to charge it really fast. If you're in a huge hurry to get back to playing with the drone or do whatever, I mean, unless you're in a military situation, I don't think it's worth risking, because you risk damaging the battery, explosion of the battery, ignition of the battery, catching on fire, especially if you do it wrong. So just Lipo charge is not a good recommendation. Hit it again, Lipo fast charge again. I don't think that that's worth you messing with, because you can set up anything and have it do whatever you want. Storage charge, that's what I want. So the only 2 charge methods that I use is Lipo charge, and I don't do discharge unless you want to get rid of a battery. Lipo Ballance charge. And so what charge does is it's charging this cell until it sees the voltage that this cell should have by the number of cells. Each cell should be around, I think it's 3.8 volts. And so number of cells times 3.8 is where it should see the full charge. And so when you put it on charge, it charges to that. If you put it on balance charge, it tries to balance charge individual cells to bring each one equally up to where it should be. So if each cell is looking for a 4 volt charge on each individual cell, then for the total amount, then it's trying to get each cell to that point versus just charging all cells to bring the overall voltage to where it wants to be. So the balance charge will make your batteries healthier, last longer, and safer. So always charge, in my opinion, with the balanced charge. So going past that, fast charge. Now, Lipo storage charge, again, is what I want. Discharge is where you would tie this into your battery. You would set it for discharge at whatever amperage you want to basically load your cell with to discharge the voltage out of it. So you will effectively kill your battery by bringing the voltage level down as far as you can get it. And that's what you want to do to eliminate a battery. If you got a battery you're suspected of, you can put it in here, set it for discharge the battery down, and then it can safely be disposed of. I've heard of people putting batteries in salt water to also neutralize them over a couple of days. There's many different ways to take and get rid of these batteries. If you have a battery that's swollen, and I've gotten rid of 2 so far, and they charged, they held a charge, they discharged, they work just fine. But it's not really worth it to keep these batteries, in my opinion, once they start to swell. Once they start to swell, they're starting to display degradation. And they're starting to display potential damage or danger. And these cells can put you out of a house. And so you want to make sure that you keep good cells. And you also want to keep them in bags. These are Lipo bags. And what these bags will do is one of these things can light off inside of that bag, and that bag can contain the discharge of the battery. When they say these batteries explode, they don't literally like explode like a bomb, but they'll go off like a Roman candle, and they won't stop until they're completely obliterated, and that's done lit your house on fire by then. So definitely store them in a Lipo bag. So we're going to go back up to, where are we at? Storage. So we're going to go to storage charge. Once you get to storage charge, hit enter, and then your amperage starts flashing. So let's go back again. This is a 1,000 milliamp amp hour battery. These are 1,000 amp hour batteries. So you can tell by size, I mean, these are vastly different in size, but they're both 1,000 milliamp hour battery. Again, this one right here, it could be a 1,000 milliamp hour battery. It could be a 900 milliamp hour battery. I just can't imagine this being a 500 milliamp hour battery, but if it is, that's about the lowest I can imagine something like this being. Correct me if I'm wrong, but that's my line of thinking. So what I'm doing here is setting my amperage at a 1/2 an amp. So this battery, being 1,800 amp hours, would be 1.8 amps, would be 1C. Well, I'm going to check this battery at 1/2 amp. So instead of being 1.8, I'm going to use 0.5. Well below what this battery is going to need even for a 1C charge. So in this case of this battery, it's a 1,300 milliamp hour battery. So that'd be 1.3 amps. Again, 0.5 is what amp is what I'm going to do with this battery. So that's why I'm checking these batteries, and I'm actually doing my storage charge on these batteries. Now, if I knew everything was good about these, the next time I do a storage charge or a charge, I'm just going to go 1 amp because it's in my opinion, it's okay to wait, and all these batteries remain good. The faster you charge a Lipo battery, the more potential that you have for degrading that battery. It's going to get hotter. It's going to be cramming those electrons in there so fast that it does. It's like, I don't know, friction, who knows? But the battery's life is shortened the faster you charge batteries. So at 1 amp, if it's calling for 1.3 amp, once I've confirmed this is a good battery, I've got a storage charge on it. When I charge it, I'm going to charge it at 1 amp instead of 1.3 amps. This one, instead of 1.8 amps. I'm going to charge this one at 1 amp. And again, say these right here, these are 1300 milliamp hours. I've confirmed they're good. I got a storage charge on them. Right here, it's got a high discharge rate of 95C. 1300 amp hours, 1.3 amps is what it would technically be a 1C charge, which is a decent charge. 1 amp. That's what I'm doing. These right here are 1000 milliamps. So again, half amp is where I'm going to check it and do my storage charge. And when I want to charge this, I'll probably do these, being as they're already 1 amp is a 1C charge. I'll drop that down to 0.8, 0.9, something like that. I'm always going to charge below 1C. If that's a bad thing to do, tell me. I really need to know, because I'm thinking that is better for the whole get up if I do that. So all that said, half amp is where I'm charging. Hit enter again, and it's asking me for the number of cells. I already know this is a 4 cell. I've already got it set for 4 cells. Hit enter again. So my charge program is set up. Hold the button. It comes up, it checks, it sees a 4 cell. It is a 4 cell. And I hit enter. It already sees the voltage. So this is already at a storage charge. So it doesn't need to charge or do anything to it. So we're good to go. So 2 clicks, stop back, and it goes back to default. I'm going to unplug my charge lead and unplug this. And so we'll take these tape batteries. Let's go ahead and check this one. But we'll take these taped batteries apart on the camera while we're doing this and take a look at them, and we'll see what we see. So again, we've got a 4 cell battery. Plug it in, fits, we're good. We're going in here. So again, this is a mystery cell. There is no markings on it. So I'm going to go in here, and we're going to go back to resistance. Everything's plugged in, and it finds 4 cells. And so I'm noticing that first cell on several of these batteries is a higher resistance. I don't know. I'm just kind of wondering if maybe the first cell in some of these batteries takes a hit somehow or another. Would repeated maybe fast charges, or just whatever the case may be. So my ohms are good. 0.0, or not point, but 0.007 on all of them, which is very consistent. And then 13 on the very first cell, which seems to be a little higher on all these batteries. I don't know if that one maybe somehow pushes out more, pulls more, or what. So I'm happy with my ohms. Now, if I see really high ohms on any of these, then I'm not going to try and do a storage charge. I'm not going to try and do anything with them. I'm going to do some research and find out what I need to do, or if I need to just, scrap the battery. So we're good on that. I'm going to back out. Now I'm going to battery meter, and we're going to hit enter. And so 3.82. 82, 83, 82. So this is also at a storage charge. So when these batteries were put up, it seems like they were actually taken care of. Now they've got some abuse. Yeah, that's kind of a rough surface. But it makes me feel better about who had all these drawn parts, because they put these batteries in a storage charge. Let's see. We're going to back out here. And then we're going to go forward to Lipo. All right. Now, again, we got another 4 cell battery. So we're going to go to amps. I'm going to leave it at a half amp. And we're still good there. I could have just hit enter and held it. It's checking 4 cell. Again, finished. It's already at a storage charge. I really don't need to do this because I've already checked the resistance on the battery. And everything was good, and I checked the voltage, and I could see the voltage is already at a storage charge. But I like to go through the process of still doing that, just in case, to make sure that everything seems right. No, I'm sorry. Here we go. So here's one of these batteries. These are the This is a Carnegie. I don't know. I can't pronounce that. Anyway, so we're going to try to step through these batteries really quick. And I'm just going to go through the process on each one. And so let's go back. Resistance. See, it's a little higher here. I've got, and it's a little more erratic and spread out. A 17, a 9, a 12, and a 10. But still, I don't think that's bad. Battery meter, and it is a little low. So this one I know will need a storage charge to it. And that could be indicative to the resistance, because I have had a battery that had a little different reading on resistance after it was set to a storage charge than it was before. So we're going to hold these to the side, because that's going to take some time to do those, and I'm not going to make you watch all of that. I just want you to see the from checking these batteries. And if my process for checking unknown batteries is not a good idea, tell me. I want to know. See, this one is also below storage charge. Let's go to resistance. And overall, this battery is a little higher in resistance. So we're going to kind of try to step through these at a decent pace here. Check resistance. 13, 8, 9, and 10. Not bad. And again. So these, I think these batteries has probably set in storage after a storage charge for a bit. We'll see, because we'll start one of these charging, because these all seem to be pretty consistent in their amount. So let's go to resistance first. And it's a little higher, 18, 13, 9, and 13. Battery meter, again, in the 3.75. And 14, 8, 9, and 9. Not bad, I think, anyway. See, this one is closer, but you'll notice that one cell is just 0.01 volt below. So what'll happen when I balance, whenever I come through and storage charge, it'll try to get these all exact to 3.82. So this will be the one that we'll start doing the storage charge on, because it'll get to it the quickest. But also with a balance charge, it'll bring these all in line so that they're all equally the same voltage. And that's what you want with LiPo batteries. You want them to be in the same voltage, each cell, but not just so that they're the same voltage. Oops, I don't want to do that. Take it off of that before I go through here. You not just because so that they're all exactly the same voltage. You want. So I'll have to check this one some, because that might be slightly bulged there. It don't feel like it. It feels like it's a little bit of a bow to it, but it's not. It's not swollen. I can't explain it. It's just like it's molded. I don't know. So let's check resistance. Ooh, that's bad. So it's showing a total of 270 ohms. So I think we got our first bad battery. Let's unplug that and plug it back in. Yeah, that's not good. So see there, and the mains voltage is 2.29. That is well below what this battery should be. This battery should be, what is it? It's a 1, 2, 3, 4. So it should be around 14.4, I guess. So that's going to be a disposable battery. And so I'll run this through a discharge, but we'll do that later. And I may tag onto this video tomorrow or something and show doing that. So let's come in here, go to resistance. See again, so all of these batteries here may be bad batteries. So it is actually showing the cells, but it's only showing 3 cells as dead and only 2.59 volts on one cell. So there's we're gonna experiment and figure out with these cells before I actually dispose of them, just to be sure. I want to make sure that there's no connection issues. And worst case scenario, I got some leads. So I mean, I didn't get this this lot of battery stuff because of the batteries. You couldn't even see the batteries in the listing. So we've got a pretty high resistance on one of the cells. I'll research and see. 27 is getting pretty high. I don't know if I want to trust that one either. So let's go to our battery meter. It's right at a storage charge, but if you look here, you got 3.27 volts versus the 3.81. So I believe this has a damaged cell. So this may still, although it's got a charge, this may be I don't know battery. So let's see what we got here. Excuse me. Hiccupping. My daughter come in and we all went out to eat. So resistance 12, 8, 9, and 10. So I think we may have a good battery here. Let's check the voltage. And we're close to a storage voltage. So we're going to pull this and set it over here in the let's check it out pile. So far we know we got 2 bad batteries or not properly connected, which in most cases is going to be just considered a bad battery and get rid of it. Because if you don't have experience tearing these babies down and doing some work on them, you can go to soldering on one of these suckers and you don't want your hands all up in here when you're trying to solder something. You short that battery out and it goes off. You may be missing some fingers. You may not have them anymore. I cut that one off when I was very young. Not fun. So resistance. So not bad. I think we got another good battery here. It's a 17. Okay battery. And our voltages are all pretty well in line. Remember, this one right here has got one cell that is wonky. I got a high resistance and it is a lower voltage than the rest. Balance charging may bring the voltages back in, and then I may watch it and try it again and check it and see if it changes. And then if it does go back down, then, excuse me, if it does go back down, then it's going to go in the discard pile, which I'm going to check these out before I actually discard. But so far, I mean, I've already gotten enough good batteries out of this to just about pay for what I paid for the lot, to be honest with you. And see, this one's all a little higher. It's 16, 13, 12, and 9, but still I don't think bad. And this is slightly over a storage charge. So this one right here, when we may put this one on, because if you put one on that's below storage charge, it will charge it up to the storage charge. And if you put one on that's above the storage charge, it'll bring it down to the storage charge. So if we got time, we may try to do both, and I'll show you how it does that. So let's pull this out. And so that's the last one. So far, I mean, these are good batteries. They're just wrapped up, and I need to check them to make sure that all that is good. These give me no like 200 and something ohm resistance, and that's across the board because I think multiple cells are just dead. And there's some wording written on here, but I can't read it. and then the voltage is around 2 volts, which is bad. You let one of these things go down to that kind of voltage, and it's potentially permanently damaging the cells. So let's grab this one, which this is. You inspect it because you see right here that we got a little damage to the side, so I may end up pulling this and putting a new one on there. I've got more of these. I can take and pull all of these leads out and push them back into a new one. But I think that's good enough to plug in. And this right here, so look at this one. This is 1, 2, 3. This is a 3 cell. So we're going to go the next lead up and plug in. And these could be not making good connection on those there. And that's another thing I want to check. So let's go in here to resistance. And it's showing higher, but across all three. But I don't think that's super bad. 17, 12, and 14. And then we'll check the voltage, which it is just slightly below a storage voltage. So this is set to bring all cells, however many there is, to 3.82 volts. And that's what I've got this programmed to bring the batteries to. That's what I'm using for a storage charge. And that's where I read into things and out of what everybody was saying online. That's what I figured. Well, that sounds the best thing. That's what we're going to do. So 1, 2, 3, 4. This is a 4. Get it plugged in. Let's go ahead and plug it on top. Go to resistance. And again, a little higher than what a lot of these batteries are, 14, 9, 10, and 11. And let's check the voltage, which it's a little bit just barely out. These are right there along with one another, but a little bit would bring it right on up to the storage charge. So I think it was, so we're going to just leave these off the side. I think it was this one was a little above the storage voltage. Oh, come on. Well, let's double check. And this one's the one that's got a little higher there. So no, that's not the one. Because I've got to do a little research on this battery. I'll probably pull apart, check the connections, check everything to make sure it's good. And I'm not going to film that because I don't want anybody potentially pulling one of these batteries apart thinking that it's just, oh man, he did it online and that was simple. It might look simple, but it's not. So we're not going to do that on film. Not bad. And this one was slightly below. I know it was one of these. It was just barely above. I lost track. I'm an old forgetful man. Nope. So this is the one that's just below. So let's go ahead and bring this up to a storage charge. So we're going to go to Lipo. And again, this is a 4 cell. We're already set up for 4 cell. I've already got it programmed at a 0.5 amp. And we're going to start. Let's check something. Storage. I forgot to look at that to make sure it was stored. Make sure what you're charging at. And 4 cell. No need to charge. So at that, the 14.8 total voltage, it's saying I don't really need to try to do this to bring it on up to storage charge. It's right there at it. So I'm going to pull that one. And if I can find the one that was slightly over. Y'all are hollering at me because you already know. You're watching me do this, and I got an old grandpa brain, and I can't remember. So let's go resistance. Yeah, so this one's the one that's just barely above at 3.84, so on and so forth. So let's see what happens when I set this one to go to storage charge. Lipo, we're already on storage charge, half a volt, so 4S. That is 1, 2, 3, 4. So that's a 4. And it's calling it finished. So it's not really, I don't have one that's high enough that it will pull it down to the storage charge. I'm sorry, I thought I could, that was enough. But if it was, say, I don't know, if it was probably 3.9 volts, then it would go ahead and pull it down. But that's what it will do. The charger will pull the battery down to the storage charge if it is not there. So let's check this one and see where it's at. And we will start bringing it up to a storage charge because I don't think there was any other ones. And because I'm looking at so many batteries here, I'm going back through and checking the resistance and the voltage so I don't accidentally grab, because I know these two are bad and I know there's potentials with these two. They seem as though they'll take a charge, but one of these, I think it's this one, so I'm already losing track. I think it's this one that has high resistance, or no, it's this one's already at storage. This one has high resistance on one cell, and I want to check things out. So this is the wrong way to go about. I'm doing this to have all these here to do this demonstration, but what I should be doing is taking a battery and checking it. Bad. Should go off to the side in a bad spot. Each one of them. Questionable should go off into a questionable spot. Good should go into a good spot. And then I should sort those to what the different cells are and how the different cells are, so that I don't get 4 cells and 6 cells and all that mixed up and lose track of what I'm doing. So you shouldn't, and in my opinion, you shouldn't have all these batteries laid out here, because like I'm doing, I'm going through all this really quick, or trying to, and I've got tons of battery here and I'm losing track of which ones is which. But I'm just trying to demonstrate what's what. And I know these batteries here, I set them all up here to be storage charged. So we're going to go ahead with this one, but I'm going to check the resistance just to be sure. And I'm going to do that with every one of these before I ever put them on a storage charge. And I'm also going to check the battery meter, which this one's so close, it's probably going to tell me, don't worry about it. There it goes. So this one's going to be put off to the side. And by the way, I can go to any of these sections and plug into any of these, and it's just fine. Okay, this one should probably take a storage LiPo battery, 4 cell half volt, and you see, yeah, see, so there's bringing it up. So you can see it flash where it says 4 SER, 4 SER. And what that's telling you is you have a 4 cell is what it found, and you're telling it it's a 4 cell. So you always want to look at that. It's only there for a short period of time. If you don't do anything, then it's going to flash back again. You got to just hold the button down again to start the charge. But you always want to look at that to make sure that you didn't accidentally tell it a different charge, a different number of cells versus what's there. There's instances where there could be an issue. So just look at it to make sure it's four cell, or 3 cell, 3 cell, 6 cell, 6 cell. That whatever you told it is exactly what it found. It potentially, I guess there could be some issues to where it's a 4 cell battery. You tell it it's a 4 cell battery, and one cell is completely dead at 0, like most of the cells in these 2 packs right here, and it thinks it's a 3 cell versus a 4 cell, and you don't think nothing about it and try to charge it. Now, I haven't tried that, and I don't know. I'm pretty sure the smart charger right here will kick it back, but if for some reason a cell is so dead that it can't even recognize that there is a cell, then potentially it could try to charge at a 4 cell and there's only 3 cells. Now, what will that do? So the overall voltage, all right, in this case, I guess it would go lower than what it should, because this is going to take 4 cells times the individual voltage per 4 cells, which I think it usually charges up to like 4 volts per cell, I think. And so if you're telling it's a 4 cell and it sees there's a 3 cell in here, and you try to tell it to charge, it should kick back and not let you do that. But if it did let you charge, then it would be charging at a 4 cell rate for 3 cells. I don't think the charger will let you do that, but what that basically would do, you told it there's 4 cells, so 4 times 4 is 16, okay? And you've only got 3 cells in there taking voltage because one is completely flat and dead. And so you end up putting, what would that be for 3 cells? Probably 6, 12. So it'd be like 5 point something volts. And you're not, I think the max you can charge one of these things is like 4.2 volts before you create damage, or probably even just over 4 volts. And so you're going to charge these cells higher than what they can withstand without having damage. And that would, in my opinion, I think that would require this to malfunction in some form or fashion to let that happen, because there was a dead cell in here and it doesn't see it. Now, this is my hypothesis. Didn't know I knew words like that, did you? I do know. I know big words. I might be from the South, but I know big words, and I even know what some of them mean. So that's where I can see there being a potential issue with some of these batteries, being with the there being dead cells or damaged wiring or something like that this can't see what's actually there. And so that's always a good check to see that it finds what you told it was there, and you're telling it what's there versus what you're physically seeing. So I think that's something that you really want to watch. Now, on this charger, let's take a look. If I hit, while it's sitting here doing the storage charge, and right here it says STO, that lets you know it is a storage charge. It is a Lipo LP 4 cell, and it is currently at 0.5, 0.6. Drop back down to 0.5 because I set it at a 0.5 amp charge, which it's going to take a little bit to get it there. See, it's already at 14.99 volts. I think 15.28 or 15 something is where it's going to try to kick out. So anyway, with that said, it's doing its thing. Hit forward, and it's giving you the individual voltage per cell in here. There's 4 cells. You can see, and I've watched this screen. It'll flash back after so long, but I've watched this screen, and I've seen one that was like 0.2 volts below the other cells, and it would slowly, and I don't know how it does it. I guess charging through these leads and somewhat through these leads, and I don't know, but it will slowly bring up a lower cell to match the other cells, and it'll be within 0.1 usually is where this charger will get it. to that storage charge or that balance charge. And so the first time you hit that, the second time you hit it, it shows you the amount of fuel equals 23%. Cells is 3.75 volts. And so it just kind of cycles through those settings. So leave it here, let it bounce back to the main screen. And this is while charging. There it goes. I thought it was going to make a liar out of me. So hit back. So here you go. These are settings that you can do. So in voltage is 15.28. Yeah, so I was right. So it's trying to get this whole pack to 15.28 volts. We know from going this way, which hold on, I'm getting out of sync. Wait a minute. Let it bounce back. Okay. 15.28 volts is where it's looking to get it. Hit back again. This is where it's at. In power voltage is 15.12 volts. Then you've got your internal temperature, which is this. And I have the cord to plug into here to strap a thermometer on here to give an external temperature, which I can set that on this screen while it's charging. And I can set that so that if this gets too hot, it kicks this charger off. Go back again, temp cutoff. That's where I'm going to set my temperature where I want it to shut off if it gets too hot. Right here, safety timer is the number of minutes to charge before it just kicks out because there's too much. And then this is the milliamp hours. It won't put more than 1300 in a deal. And so the end voltage, again, we're back at the end voltage. So let me let this pop back up. And that's keeping track. It's been charging. I've been talking for 7 minutes. Wow. Okay, so this isn't giving me a count or a voltage on where the overall voltage is yet. But it's right here, 15.04 volts. The smaller one, you hit forward and it gives you individual cells. It gives you the power level, and then again it gives you the voltage that it's currently at because it doesn't display it on the main screen. That's where I'm getting confused. The bigger one here, the AC, has it on the main screen. So you can see it's at 15.05. We're trying to get 15.28 is what we're looking for. So while that is doing its thing, and I'm just going to put these two. I know we got the cell issue, and I think it's a good battery, but I don't know yet. These I think are bad batteries. Potential connections, I don't know, but these will be disposed of if I can't figure out that there may be a broken connection in here or what. But I'm putting these together in this is a problem. I need to check it out before I do anything with it. That's the pile those are going in. So what I want to do is get these back here and see what is what here. Okay. Let's start with this one. And if I like unwrap these and they puff up, then even though they've got a storage charge, they're holding a storage charge for who knows how long, and everything seems fine. They are going in well, I think we got to figure out what we're going to do with these and how we're going to dispose of them. That's the pile they'll be going in. Because again, like I said, it's not worth risking, one of these batteries going off. So let's try to get this tape off here. There's the end of the tape. And I can see already why they wrapped it. But let's get this on untaped, untaped up. So there we go. So Now, if you look at that battery, it's not puffed, it's not swollen, it's not mal-shaped or anything, but the rubber casing here is split. Now, it's not from any puffing that I can tell in any of the cells. The cells all seem to be just fine. I can see the side of the cell there, but the plastic, or I guess it would be the rubber shrink wrap that they initially put on here, has started to tear. And so they taped it so it was a good outside surface. They didn't want any of this stuff just popping open and being exposed. So this battery looks like a 1300 milliamp hour. Yeah. So this was a 1300 milliamp hour, where these were 1000 milliamp hours. So this would be a 1.3 amp. And I did the tests, and we'll do charges. The test charge for storage charge at 0.5 amp. And when I charge it, it'll be at 1 amp. So anything, I'm going down like probably, I don't know, 1/4 amp from 1C. And so I think that's a good, safe, protective, because these have seen use, but I don't think they're in any way bad. So I think they've got a lot of life left in them. And so we're going to use that. And so what I'm going to do is I'm going to tape this back up again, because I don't have any shrink wrap this big. And if I did, I wouldn't waste it on this. Electrical tape. That's what I do. So now that I've got it exposed, I've got my information on it. I'm going to see if I can read my C, my discharge capacity, which is, so like if you look right here, you can see 95C. So that's the discharge. That's what this right here, that's how many amps it can push out at one time without damaging this battery potentially. And so you're charging it at 1C, but it can discharge up to 95C. And there's a formula to figure out what the C rating is. But if you look at this right here, at a 1300 milliamp hours, 1.3 amps is 1C. And I don't know that equates to this right here, but there is a formula. Maybe I'll see if I can find it and pop it up on the screen or something like that, so you can figure out how many amps this thing can put out at one time. But at that 95, I want to think 40C is like 7 amps or something along those lines, is using that formula. I only did it one time, but anyway, you get the picture. So that's what we've got here. So I'm not concerned about this battery. I think it is perfectly fine. I'm okay with it being wrapped. I'm going to wrap it again. I'm going to get the information. I'm going to wrap it. I'm going to write it down. I'm going to wrap it with tape, and then I'm going to immediately put a piece of paper on here, rewrite the information, and I'm going to cover that with shipping tape, clear shipping tape, so I can see the information that's on there. So if I die, somebody else can charge it, or when I die, somebody else can charge it, and safely charge it at that. So here we have this battery, and I really hate to take the red tape off, because I don't think I got no more red tape, but that's okay. That's okay. We got to check this out, make sure everything's good. And just as a little bit of useless information, because I'm full of it, in more ways than one, multicolored tape, electrical tape. Why? Why would you have it? Phases. You would do that for phases. Brown, yellow, and orange. On 3-phase, you would mark each of your phases, and I forget A, B, C, which color's what, but you got the colors for the phases on your wires. So when you run them up into your disconnect or your starter, or exactly how, you've got each one of them marked, and you've marked each one of them on each end of your wire, so you hook them up to the same deal. And I think I've mentioned this before, but with three-phase industrial motors, if you hook them up, all three phases, and it turns one way, and you want it to turn the other way, go back over there on only one end of your wire connection and swap two wires, and it will turn the other way. And then a buddy of mine from many years ago who was hooking up a motor to a $10,000 hydraulic pump can spin that pump backwards and blow it up. Twice. Oh my gosh. $20,000 worth of pumps. And again, so the rubber has split on here, and I'm looking at the cells. They do not look swollen. There seems to be no real issues with them, so I'm fine with this cell as well. And it is a 1.3, and that's a 1300 milliamp as well. So I'll show you something, but it's not a rule of thumb. You see here, 1300. You see here, 1.3. This one doesn't say. Right here, it says 1.0. That one says 1.0. That's 1,000 milliamp, and 1 amp is the charge rating on this. So I've seen them to where they'll put like something, point something. And what I've found is the cheap Chinese ones will say 5.8 or 6.2 or whatever, making you think that it is a 6,200 amp hour battery, and it's only a 4,800 amp hour battery or 2,400 amp hour battery. So that's not a rule of thumb that you can use to say, okay, it's a 1 amp charge. You need to look at your amp hour rating on your battery to decide what your C charge rating will be. So I'm good with these batteries here. I'm just going to have to do some repair. I'm going to retape them. Both of these are 1.3s. And so I'm all good with that. This one is the one that we want to look into. And I wanted to see, we're still recording. Oh my gosh, 1 hour and 2 minutes. I can't believe it. I definitely have to try to see about cutting this down. It's just a lot of times I don't have the time available working and everything, and I'm going to be traveling next week to go through all of the video to properly break it down to a shorter video. I'm okay pulling all this tape off. I don't think there's any big issues. All right, and so this is a race drone lithium polymer battery. Okay, hold on. A lithium polymer battery is different. Let me check something. No. It's late and my brain is getting fried. You have, let me see something. Hold on just a second. Okay. Sorry. I was worried there for a second because let me go back to charging this. And I'll explain why. So I'm sitting here looking at lithium polymer and I'm thinking in my head lithium ion. So there is a little difference between one of these, one battery and another one. And I don't know that there would be any difference in charging. It's just I don't want to take a chance on messing anything up because I am new to all this and I'm learning, and I need you to fill me in on where my knowledge is got gaps in it from my research. Because I mean I'm watching YouTube videos, I'm reading, I'm checking things out, and we all know that everything on the internet is absolutely true, but sometimes you you listen to what the internet says and you don't got all your fingers no more. So tell me where I am mistaken in my research in learning about this stuff. So lithium polymer, 1300 milliamp, 11.1 volt, 3 cell. And yes, it is a 3 cell. This looks factory, but I'm probably going to see about exposing. I don't want to just pull all this apart because I'm not ready. I'm not ready to tape it all back up yet. So I need to just find out if this is an add-on by somebody did this, or if I can get this exposed and see the connections, and I can tell whether either it's factory or a super pro soldered it. But if it's factory, it's all going back together, and then that connector right there was just kind of rigged and added on by someone, because I can't imagine a factory leaving, using a 4-prong plug in a case like this right here. I mean, you can literally take these two and plug them into one another, which would be not smart. And I just don't understand why you would have this, because that would short the batteries. I don't know. I just got to do a little bit of research on the battery and see what's what. Why it. That's got to be something that somebody added for some kind of specific purpose. I don't know. Anyway, so I think these batteries that were taped up are fine. And when you see these batteries in the future, especially so these have issues, these were taped up, they're going to be taped up again. And then probably even these where they got a little bit of scarring on the outside. Not that one, but probably this one's got a little bit of scar in there. I'll go ahead and tape those again, or tape those for the first time, to just for them giggles and stuff, to feel good about how it's done. This one is the rig up that I found in there, and I'm pretty sure. Let's grab my meter, and we'll try to do a quick voltage check on this one. Let's go to DC voltage, and I don't know, we're just going to assume that center's positive, and it is, and it's 7.48 volts. So going center positive, outer negative, 7.8 volts. That is accurate, because if you do this the other way, just in case you don't know, it'll show negative 7.4 volts. See? So if you hook it up backwards in here, it shows a negative. And then you can put positive in the center, negative on the outside, and it shows a positive 7.4 volts. And so I got 7.4 volts. These would be 3.8. That would be 6, 7. That's about right. So I think these cells are good. I feel comfortable that these 18650s are good. So I've got to figure out what I want to do with this little pack. I don't like it the way it is. I'm not comfortable with it because it is it's not tidy. And if you have a 3D printer, then you see things like this and you think, I can print a case for that. And I really like this because it's already got this battery management board on here. It's got that button, which I don't know what that is. I'm just kind of thinking that this was probably taken out of a like a cell phone battery pack or just some kind of something. And this right here, the battery management board they pulled out and they rigged up this whole deal right here to make this pack. And I'm just not comfortable with I think it's a cool idea, but I don't know how they've got this wired. If I can plug this into here and charge this that away. I don't know if this needs to be plugged in to do the charging. I've got to see what's hooked into this board and where this board is hooked into these batteries. It looks like these batteries on the back are looped from here to here, which this would be the negative sides looped together. And so I would assume that it is in series, which would, no, I don't think so. Wait a minute. If these are hooked together, both negatives, then I guess that would be parallel, right? I don't know about battery architecture. You've got 3 leads coming out, which it's going to tell me that I would assume you would have probably 3.8 volts and 3.8 volts and then negative, and together they give you that 7. Let's check that. Let's check that and see, because that'll tell me. And I'll explain, kind of, hopefully, what I'm looking at here. So I'm assuming that the black is going to be negative. Let's find out. And so I'm getting weird readings. Okay, so when I go to the center wire against the outside wire, I get 3.7, which is 1 cell, and I get negative, and I get positive. Well, hold on. I get positive 3.7 and negative 3.7. So I guess the purple wire is the ground, or I would assume, because when you get, it's like minus 12 volts, plus 12 volts, 24 volts. So I'll have to do, I'm just going to have to pull this apart and look at it, see how it's wired, check the internet and see what I can figure out as to how they got this wired up and what this plug is for. Now, this is the reason why I'm very iffy about trying to plug this into anything to do anything, because without knowing for sure how this plug is wired, I don't know which one of these for sure is positive, which one of these for sure are negative. I am assuming that this is plugged into the battery management board, or it may just be plugged into each of the cells, because I'm getting the full 7 volts off of this right here. And so potentially that would plug into their device they created this for to begin with. Because normally the male connector like this is your voltage supply plugging into like your goggles or your radio or just whatever. And so this right here is just, it's kind of wonky, floppy, and I don't know how well the connections are done. Let's take a look at that. That's some pretty good soldering. think the soldering is good. So they soldered them good. I would come back across with some more heat shrink here, a larger piece on this barrel coming down onto the wires, and heat shrink that to seal that up even better. And I'd probably, secure this better so it's not flopping around on here. But again, I got to find out what these leads are connected to, how they're connected, and what they mean in relation to this board. This is got to be a battery management board of some sort. Yeah, see the blue wire. Yeah, it is the negative. See, because the blue wire runs from here to back here. So you've got both of these looped together, and you've got the blue wire, which is negative on this lead coming back to here. So this is kind of set up like a LiPo battery, as best I can tell. But I'm taking all this tape off and making sure about this. But from what it looks like to me, the center tap is the negative, and the white and black are the individual cell voltages, which would be the same as a 2-cell LiPo battery. But only they're using 18650s to achieve that with. And so by what I can see right now, I'm not taking a chance until I pull it down and be sure, this is how I could charge this, and this is what they're using to discharge or power the device that they're working with. It's pretty cool. Whoever built this, I believe, understands a whole lot more than I do, because they built this just like a LiPo or a battery, a 18650 battery pack, like this one right here. And this is a good battery pack, but I have no charger for a Lynx in any way. If I ever come across one at a yard sale, I'm getting it so I can charge this battery. So and this is out of the top of an old DeWalt 18-volt battery. Anyway, I don't know what it is. We'll figure it out one day. And I've got ideas of making this a battery pack for a portable soldering setup, but it's 40 volts. And I don't know that I've got any type of, it's only 3 leads in here, so I don't think I have a 20 volt connection. I think it is 40 volts only. And then you've got the sensing connection right here for probably maybe temperature or just whatever. I'm not sure. Regardless, that's something else. So I'm going to call it quits here. This is still balance charging, but it's almost there. You can see that is at 15.27. And the cell is just as cold as it can get. It is not hot in any way, shape, or form. Because I am charging this to a storage charge well below its tolerance. And its tolerance on this one is 1.3 amps. And so it's like less than half of what you can charge this safely at per the manufacturer. So anyway, once this hits the 15.28 volts, this will give an alarm and let me know. Now, I would not allow this to happen on its own. I won't walk away from this. I have to be here the whole time this is happening. And so that's why this is going to take a while to bring all of these to a good storage charge. And I'm going to go through the process of checking my resistance first to make sure that I don't have any cell that may be way out of spec or something. And then I'm going to check my overall voltage on it to make sure it's not so low that it is dangerous to try to charge. Then I'm going to go and do a storage charge on the batteries, and I'm going to do that with all of these. And I'm going to, like I said, rewrap these with the information written on the outside. We're good there. I have another little setup right here with some 18650s here. These are more of a commercial grade 18650. Versus these right here, I can tell you by looking at them, these were in a device and not intended to be taken out. So that's why that's the way those are. So with this device right here, it's got an on-off switch, and it does the exact same thing this one right here is doing. It'll give you that full 7 point whatever volts. I've got 2 leads that were in this. This was in a kit. Doing that right there is dumb. But the switch is turned off. The switch could fail. And then you'd be shorting these batteries against one another. 5,800 milliamp hours. These are Chinese, and it's probably not 5,800. But they do have a little bit of weight to them, so they might be fine. I don't know. But this is kind of the same difference. These would have to be taken out of this and individually charged in a regular charger, versus this right here has it all built in together. So I'm kind of thinking I might actually incorporate this into this as a power pack. Yeah, I think we're going to do that. We'll make a video on maybe doing that, but I've got to understand how this works, how it's put together, and how it is done. This is already everything I need to do that. So cool. That is a future plan. So again, I thank you guys. I appreciate you guys. And I really hope I don't put y'all through a 100-hour and 20-minute video. we're gonna have to trim this down. So I may just, I don't know how. It may be a while before you see this video, so I can get a chance to actually edit it. This is way too long. But I appreciate you guys. I thank you, and I enjoy spending time with you. And I will see you next time. Your time is very important to me, and I thank you for spending it here with me. Thanks, and God bless.